Today I'm gonna cover angle properties. I'm starting a series in geometry, but before I go into things that are a bit more complicated, I would like to make sure that everyone knows what angle properties are. So firstly, I'm going to talk about types of angles. There are four that I've listed here, and they are marked with a lowercase letter, which is used to refer to the angle that's on the right. Okay, so first is the right angle, which is this one. A right angle is an angle that is 90 degrees. Pretty straightforward. An acute angle. An acute angle is an angle that is less than 90 degrees. An obtuse angle is an angle that is more than 90 degrees. A reflex angle is an angle that is more than 180 degrees. So, usually when you write an angle like this, it is assumed that the angle you're referring to is this one, the smaller one. But if you want to refer to the larger angle, you have to explicitly state that it is a reflex angle you're referring to. Okay, so do keep this in mind. Now, let's move on to the second point. The second point, I'll go into angle properties. So there are a few here that I've listed. I'll go through them one by one. The first one is angles at a point. So what it really means is that one revolution or one round is 360 degrees. So here, can you see there's like a point in the center, okay? There's like a point here. So they are cut into four angles, okay? It's like cutting a pizza, right? You have a pizza and you slice it up for different people. So it's a weird pizza arrangement here because normally you don't slice pizza like this, but all the angles add up to 360 degrees. So just keep in mind, one full round is 360 degrees, okay? So let's say if you're given angle A, B, and C, and you're asked to find angle D. All you have to do is take 360 minus A, minus B, minus C, and you will get D. Now, next I'll come to is supplementary angles. So it's a little bit similar to the first one, okay? So instead of at a point, I have one straight line, okay? And so it's a little bit of a follow-up from point A, right? So half a round is now 180. It makes sense, right? If one full round is 360, half a round is 180. So here I've written A plus B is 180 degrees, okay? Some may call it angle on a straight line. So it depends on how your teacher teaches you, okay? Now I'll come to point C, which is basically also a follow-up from point A and B. Complementary angles is pretty straightforward, okay? Refers to this one, okay? Right angle is obviously 90 degrees, a quarter of a round, okay? Means 360 divided by 4 is 90 degrees. So 90 degrees is a right angle, so all the angles that are in this 90 degree angle, they will all add up to 90 degrees, okay? That's all there is to it. Angle A plus angle B is 90 degrees. A plus B here will give you 90 degrees. So A, B, C pretty much support each other, okay? Next, now we're going to things that are a little bit more confusing. D, vertically opposite angles. So here, all you have to do is identify two straight lines. Okay, if you have two straight lines intersecting each other, there will be vertically opposite angles. So here, angle A will be angle B. Okay, this angle here and this angle here are also vertically opposite angles. So you just need to remember this. That's all there is to it, okay? Next one, alternate angles. Alternate angles, now the requirement, you need a little bit more things here, okay? Rather than just simple angles. You need a pair of parallel lines and a straight line intersecting two parallel lines, okay? Here can you see? Here is the parallel line, this is the straight line. Then, you just need to take note of a Z kind of formation, okay? So here I've written a Z, right? So this angle is the same as this angle. Okay, but there is more than one alternate angle here. Okay, I'll draw it for you in this little space here. So given this, right, there's another alternate angle here. Okay, actually there's more than one here. This one is also an alternate angle. Okay, doesn't really look like a Z, it's more like a slanted reverse Z, but it's still a similar shape. So you just need to remember this shape, okay, this kind of shape. This is alternate angle. Angle A is the same as angle B. Okay, now come to the next one, which we call corresponding angle. So corresponding angles, again, is the same requirement, a pair of parallel lines and a straight line cutting it, okay? So here, angle A is equals to angle B. So basically, all you have to remember, the shape is something that looks like this. This and this is the same, okay? Like two L's, up on top and on bottom, okay? There are actually more than one corresponding angles here. The one in green, can you see? It's also a pair of corresponding angles. Same for this one and this one, okay? So now we come to the last one. Now this is how I call it, angles between parallel lines. I'm not sure what's the formal name, but I think this sentence is quite intuitive for me. So it just means I have a pair of parallel lines here, again, and a straight line intersecting these two parallel lines. And I have two angles between these parallel lines. Can you see? A and B. And the angles between parallel lines will add up to 180 degrees. Note that if it's not parallel, obviously this will not work, okay? So they will have to be parallel. So this applies not just to this kind of shape, okay? We can talk about trapezium, okay? There's also rhombus and parallelogram. Basically any kind of shape that has at least a pair of parallel lines, okay? So of course a rhombus or a parallelogram would have two pairs, but a trapezium, let's just look at these two. These two would add up to 180, okay? Here, this two would be 180, this one and this one would be 180. So naturally, these two are the same, okay? So this is basically all that I want to cover for angle properties. Thank you for watching. I hope you have a nice day.